Hello and welcome to the solution guide for Roast at the Round Table by myself, the Pedaling Pianist. I've had a bit of trouble deciding on a difficulty rating for this puzzle. I don't think any of the individual steps are that hard, but it can get quite fiddly deciding which questions to ask at certain stages. So if you do form an opinion of how difficult this puzzle is, please do let me know what you think. Anyway, let's dive into it. The rules are we've got normal Sudoku and anti-knights. So cells and knights move apart in chess may not contain the same digit. Everything else is standard as it appears in the grid. So a digit in a circle shows how many circles contain that digit. We've got normal German whispers, normal inequality, normal Renban, and normal X. So they sum to 10. Okay, the first thing to look at is the circles. There are 10 circles in total. The first question to ask is, can we put a 5 in any of the circles? If we're putting a 5 in any of the circles, then we must put 5 5s in circles. The circles occupy 5 rows of the grid, so we must put a 5 in a circle in every row that has a circle, including this one. But this, by knights move, rules out fives from all of these positions, and so it can only be a 2 at most. In fact, actually, that is true. Whatever the case, whatever that digit is, it is a 2 at most. So if we don't have any 5s or higher in the circles, then the highest digit that we can have is a 4. So we must have 1, 2, 3, and 4 to add up to the 10 circles that we've got. Where does the 4 go? Well, can it go in one each in these kind of boxes 2, 4, 6, and 8? No, because if it did, then in box 5 it would have to go there, which is wrong because of knights move reasons and circle reasons and all sorts. So it doesn't go in those positions. It must use this kind of escape valve over here, which means it can no longer go in there. So it must go in here and in here and in here. And by knight's move, we can rule a 4 out of there, put 4s into there and there. And now this can't be a 2 anymore because in order for it to have been a 2, it had to use the escape valve. So it must be a 1, and we now have 2s and 3s occupying our circles. Now, for the next bit, you need to know a bit about Fistmafel and also Potato Head. Uh, so I'm not going to prove them, but I will just say that the Fistmafel theorem is that these 16 digits in the corner 2x2s are the same as the 16 digits in this ring. And the Potato Head theorem is that when you have Knight's move as well, then you can only have a maximum of one digit not appearing in the Fistmafel ring. The way to imagine that, let's just reinstate those, is if we have, I said I wouldn't prove this, but it's fairly easy just to send you in the right direction if you haven't heard of this theorem before. If we try to put a digit not in the red areas, i.e., not in the Fistmafel ring, then they must go in those positions. Now, where does the red digit go in column 5? It can't go in here because of we must have a yellow, a non-Fistmafel ring digit in either here or here, and putting a yellow digit in either of these rules it out of both of those. It also can't be in there because there's a yellow here or here, so it must go in here. Similarly, in row 5, it must go in, so it must go there. And only one cell can possibly occupy the middle digit, the middle cell of the grid. So that is the only digit that can possibly not appear in the felt ring. I said I wouldn't prove that. Never mind. Good. So if there are any digits that don't appear in the Fistmafel ring, then in this case it must be a 1. So we must have appearances for 5, 6, 7, 8, and 9 in the Fistmafel ring. Good. Right. So where does the 5 go in the corner 2x2s? We know there must be one, at least one in the corner 2x2s. It can never go on a German whisper line, and it also can't go on an X because it would have to be accompanied by a 5, so there is a 5 in that domino. We have 8 low digits already in the Fistmafel ring, but we can only ever put one low digit on a German whisper domino. So one there, one there, one there, one there, one there, one there. We can only ever put one low digit on an X as well. So That's 7 low digits. The eighth low digit must be there to accompany, whoops, 2, 3, or 4, and 5. So the eighth low digit must go in there. So that is it for low digits. We are at capacity for low digits. We cannot put any more low digits in because we can't put 2 low digits across an X or 2 low digits in a German whispers. That means that we can no longer have any ones in the Fistmafell ring or the Fistmafell 2x2s. It is now confirmed that 1 does not go there. That means we can ask where 6 goes. Well, 6 cannot go on a German whisper line now because it would have to be accompanied by a 1, and 1, we just said, is not in the Fistmafell ring. So 6 must go down here. It's not in this domino, we've already pencil marked it, so 6 must go across the X, where it must be accompanied by a 4. We can do a bit of work with 4s now. That 4 resolves that by knight's move. We've got a 4 exactly there because of a bit of knight's move trickery, and also there. We have a 4 there or there, and by X-wing, we must have a 4 down here, and it goes in here. Now, by German whisper, the only digit that can accompany a 4 on a German whisper line is 9, and by normal Stoku, we get a 9 here. Now, all of the other German whisper lines, the low digit on them must be a 2 or a 3 now, because we've identified most of the 4s in the grid, and we don't have any 1s in the Fistmafell 2x2s. So we must have a 2 and a 3 in this 2x2, 1 to go on this line, 1 to go on this line. Now, what low digit can we put on the X? It can't be 2, 3, or 4, so it must be a 1, and it must be accompanied by a 9. Now that the 9 has gone in this box, the 3 must be accompanied by an 8, and now that the 8 has gone, the 2 must be accompanied by a 7. These are also from 2, 3, 7, and 8 because they can't include a 1 because of what we said earlier. And now we can do a little bit of colouring. I'm going to give this a yellow and orange pair, and this is also going to be yellow and orange. And we will make this blue and purple. Right, can this be yellow and or orange? And the answer is no. You could say, well, this could be a 3 and 8. We know that these will be 5 apart. Yes, that's part of the reason why I've coloured them. We know that yellow and orange are exactly 5 apart, and blue and purple are exactly 5 apart because of the way that the digits will have to be distributed in this 2x2 to ensure that they are at least 5 apart each. So these are exactly 5 apart. If they were a 3 and an 8, you might say, well, this could be another 3 and an 8, or it could be a 2 and an 8, i.e. we could repeat the 8. But if we repeated the 8, then we would expect to see an 8 over here, and we cannot put an 8 over here. Similarly, you could say that this could be a 2 and a 7, and we could put another 2 and a 7 here, or a 2 and an 8 here, i.e. we could repeat the 2. But if we did that, we'd have a 2 here, we'd have a 2 here, and we'd have a 2 in here. But we know that all of the 2s that appear in the Fistmafell 2x2s around the outside, when they appear in the Fistmafell ring in the middle, they must appear in these circles because these are all of the low digits that we have in the Fistmafell ring. In fact, actually, just to help emphasize that point, let's label these as all of the other high digits that we must have in the Fistmafell ring because of the logic we did a minute ago. So if we had 2s here and here and here, that would be too many 2s in circles. So this cannot be yellow and orange, it must instead be blue and purple. We can narrow this pencil mark down to a 5 and a 6, eliminating 5 and 6 from here. 9 comes out of all of those places and there as well because of this 1-9 pair. And in fact, in this row, a 9 is ruled out of there, and 9 must go there. Now, can this be a 9? No, because it rules out both of those, so that's not a 9. So now in the Fistmafell ring, the second 9 that we know must exist somewhere has to go there. Now in this box, a 9 can't go there, can't go there, can't go there by knight's move, and can't be less than something, so a 9 goes there. In the middle box, 9 goes there or there, and so in this box we get a 9 just here. The next thing we can do, orange and yellow form a pair there and there, so they must appear here in this box. So that's not a 5 or a 6. And actually, because this is a 2 or 3, let's say that the 2 or 3 is the yellow one and the 7 or 8 is the orange one. That cannot be yellow anymore, so that is yellow, so that's the 2 or 3, that's the 7 or 8. Purple and blue must appear in here and also in here. Um, where does the 7 or 8 that exists in purple and blue go here? Let's say that the blue is the 7 or 8. Where does blue go along here? It can't go there, can't go in there, and it can't go there or there. It must go here. So this is a blue 7 or 8. We can take blue out of here. Now, where does purple go in this row? It must be the digit that goes with the 4 in this pair. Where does yellow and orange go in this row? And they both have to go over here. We said yellow was the 2 or 3, that therefore can't be a yellow. Now, where does yellow go in this row? It can't go in this box. It can't go here because that's not a 2 or a 3. And if it went in either of these, it would rule out both of those by knight's move. But we know there must be a yellow in there. So this must be a yellow and the 4 that we've already pencil marked in. Now, where does a 5 go in this row? There's a lot of these kind of questions in this puzzle. 5 can't go there because it rules out 5 and 6. It rules out a 5 from both of those potential positions. So 5 must go along here. It's not actually there because of that 5 over here. So there's a 5 in there. Now, where does a 5 go in this box? It can't go there again because of that, and again because of this kind of weird knight's move domino trick, we can't put a 5 in either of those, so there is a 5 in there. So that rules out 5s from those positions and gives us a 5 just here. Now in this row, a 5 must go in here, and actually a 1 in this box is tucking into this domino as well, so that becomes a 1-5 pair. That also gives us a 1-5 pair in this domino. To complete this row, we could have done this earlier actually. This is a 1, 7, and an 8. This 7, 8 doesn't appear over here, and it can't go there by knight's move. It's not any of these digits. Actually, we can tidy that up. There can't be a 4 over here because of that 4. So this 7, 8 must repeat exactly here. And to complete the box, this is a 2 or a 3. We don't know which colour just yet, but it is a 2 or a 3. Just to be a little bit less confusing, let's just give a white flash to those. We don't know for certain that that is an orange. Good. Right, the next step is to do with 5s. Yes, 5 in this column, actually. We can get that straight away. That's going to go there, and that's going to be a 6. And now, where does a 5 go in this column? Again, this is not an easy question to ask, but I think it's a fair deduction once you've got the question. It can't go there or there because that would rule out both of those. It's not 9, it's not 1, it's not 7 or 8, it's not 4. It's not there because of knight's move, so it's there or there. Can it go on the Renban? That would have to be consecutive with 5, and it's not 6 or 4, so it can't go there. So that must be a 5. This is a purple-yellow pair, which means we can actually ask where purple goes in this column. And now that we've ruled out purple from this cell, purple now must go here. This digit is a naked single. It's, again, not easy to spot, but it can't be 1, it can't be the yellow 2 or 3, it can't be 4, it can't be 5 by knight's move, it can't be 6 directly, it can't be an orange 7 or 8, it can't be a blue 7 or 8 by knight's move, and it can't be a 9 by normal. So this is what colour is it? Pink 2, 3. Now there is definitely a pink up here, and all 3 of those cells see that cell. So that is not pink, so it's not the 2 or 3. So this must be the pink 2 or 3. That gives us a pink 2 or 3 just here. And to complete the box, this actually becomes a 6. Now, in this box, where does blue go? Not there, not there by knights, not there by knights. It must go exactly there. And now that's huge because that means this has to be orange because it's no longer blue. Orange rules itself out of those and becomes that one. So this needs a blue and a 1, and the blue takes it out of there. So that's a blue. That must be a 1. Now, where does 1 go in this box? It can't go there. Yeah, all of these are ruled out fairly normally. And it can't be bigger than anything. So that is a 1. Now we need this digit. This sees a blue and an orange 7 or 8, so it can't be 7 or 8, so it is a 6. That means that's not a 6. That means that's blue. That gives us a 7-8 pair. In fact, actually, the last digit in this row is a 6. Now, what's next? We can do a bit of work on fives. This 5 rules out all 3 of those, puts a 5 in there, so that's a 5, that's a 1. And we can actually do more work on 5s in here, not in there by knights, and those all have other pencil marks in, so that is a 5. That actually tells us that this must be blue, and it's a 7 or 8. We need in this box, actually, yes, in this box we need an orange 7-8 to go in here, and we also need the other 2-3. We don't know which 2-3 that is, but we need both of a 2 and a 3 and an orange 7 and 8. If the 7 and 8 is going on the inequality, it must be the bigger one. It must be bigger than the 2 or the 3. So this is orange, and it is 7 or 8. That means this is orange, this is yellow, so that's 7, 8, that's 2 or 3. Now, that yellow rules that out from being yellow, so it is actually purple instead, and that's yellow just to complete the box. Yellow is now not there. It is a 4 instead. That puts a 4 there. That means that can't be 4, that can't be 4, and it is yellow. That means that's not yellow, that's not purple. This is purple. This is not purple. I'm sure the reason you logged on to this solution guide is to see me floundering around with the colours. I'm sure that's what it was. Right, okay. What's next? Yes, yellow in this column must go here. So that's not yellow. That is yellow. So that's not 7 or 8, and that's not 2 or 3. So this is a 5 and an orange. This is a 6 and a 1. We will see how that gets resolved. That 5 does that, and then the 1 by knight's move sees that. This is a 1 and a 6, and that 1 resolves it. And now we have 2 6s pointing into box 5, so that's a 6. That knocks a 9 pencil mark out. 9 now in, well, actually, in this row, that becomes a 6. Sorry, this column, and that becomes a 6. That's now a 5 or a 7. 9 now in this box goes exactly there. 9 and 1 get resolved. 1 has to go there. This is a 5, 7 or 8. This is a 7, 8 pair. How is this all going to get resolved? Well, this is where we cast our minds back right to the beginning of the puzzle, where we have the circles rule, because we now have 3 pinks in circles and 2 yellows in circles. So in order to make the circles rule work, we must make yellow 2 and pink, let's just be careful with that, 3. That means that blue must be 8 in order to make these German whispers work, and orange must be 7. And now that we've got a 7 there, that resolves our Renban and gives us a 5 there. That's a 5. That is not a 5. In fact, it's a 3, finding its position. So that gives us a 3 just there. That's an 8. I suppose it's important that I finish off the colouring. That makes that an 8. That becomes an 8. Those both become orange 7s. And that's a 5. And what are we missing? 8 from there. Oh, and we're missing 2 from there. Good. And that is the solution. So quite a lot of bitty deductions to do with where does this digit go in this column or this row. But it was always to do with columns and rows 3, 5, and 7 all the way through. That's where most of the deductions were found. So I think it's fair because it's thematic, and a lot of the deductions were similar to other deductions that you make in the puzzle. That's what I would argue, but I also understand that it is very fiddly and very tricky to get through some of that middle stage of the puzzle. Anyway, I hope you enjoyed, and please do leave a like, comment, subscription, all the usual things. Thank you very much for watching, and I will see you next time. I didn't colour this too, did I?